So after playing around with some of the different temperature settings, we end up with this. And I'll tell you what these settings are here in a moment. But I just want to point this out. This is using, again, temperature. We're not using divergence. We're not using pressure. What I've found with divergence and pressure is that it doesn't really work as well as temperature does in this situation, because we have the swirly motions happening with temperature. And by introducing those extra particles, we get more of that churning motion within our smoke plume here. So my recommendation for these internal particles is to either use temperature and source directly there, along with the buoyancy, or you can do that with fuel. So we can add fuel units with the particles in here, and that will give you control with both temperature and expansion, and divergence as well. So either way, you can go either way on that. That's going to add a lot of interesting detail to how this thing evolves over time. Right now my settings are a min value of 0.25, max value of 1, and if we go over here to the gas particle to field, we have a calculation set to maximum and a source pre-multiply by 5. So this is about 5 units of temperature that I'm bringing in with these particles. And I'm not doing too many particles either. It's just kind of roughly in there, just small little pockets. So where do we go from here? Well, right now we're sourcing with density, right? And at every single frame, we have particles being spawned. I don't necessarily want that though. I want there to be an initial burst of particles with the density, and then as we source less density in our simulation, I want there to be less particles. So I don't want it looking at the whole plume and just adding a bunch at every single frame. I want an initial burst, and then I want only particles sourced with new density as we go along. Hopefully that makes sense. It basically means that, yes, we're killing these particles over time, but I'm not just spawning it over the whole plume every single time. So what can we do for that? Well, I have an idea that will work pretty well. We can add a new field, and we sort this in with density. We say, okay, we have density. The target field is going to be our scatter points field. So let's copy that. We have this thing up here called create missing fields. So what that will do is it'll create the scatter points field on frame 2. If we go to our geo spreadsheets under our smoke object, we do in fact have scatter points right here. But it's not the same as these other guys, because these other guys actually have a container, right? They actually have something in here which represents the field. So what I like to do is create my own container as well. Right click the smoke object, say allow editing of contents right there. And then all I'll do is simply create a copy of one of these scalar fields. Let's call this our scatter points. The data name is also called scatter points. It's a scalar field, so it's using float values. That's good. And we also need a visualizer over here to plug in. So we're just going to borrow from all the settings that the other scalar fields have. Now in this scalar field, it looks like everything's pretty much set up to work right away. So all we need to do is merge that in. And there's one more thing. We need to go to our Pyro solver. Under sparsity, we need to also add scatter field right here, or scatter points, that is. And for the resizing, we also need to add scatter points so that this resizes the field at every single step, like it does for density and flame and all the other things. As soon as we have that, let's also advect this field. So we can go to advection, add in scatter points, and that will advect those values just like it does for density and flame and everything else, right? And as soon as we have that, we're pretty much good to go. Now, what are we going to do with this field? Well, I want to first of all copy density over, and then likewise over here, let's create density and scatter points. Copy that over. And unlike density, I want this field to dissipate more quickly. So I'll create a gas dissipate, and we are going to be dissipating scatter points. I'll do a subtraction rate here of 2, and I'll plug that into our extra forces. Now, to test this, let's go to our DOP imports and bring in the field that we just made called scatter points. Set the visualization to invisible, and then we're going to go forward a few frames to make sure that it's actually going through properly. On our volume slice, I have this set to scatter points, and as we scrub through these frames, we can see that we are dissipating this field much more quickly than we are with density, which is exactly what I wanted. I basically wanted the same thing as density, but we have the ability to dissipate more quickly. Now from here, we can use this as a mask for the scattered points. And one thing about the scattered points that is going to be kind of tricky at first is that it doesn't really know what to do when there is no density present. And so we actually need to come up with a way to set the scatter points to 0 if there isn't any sort of voxel value above 0. Because otherwise this will just try to scatter at the origin, or it'll try to scatter everywhere, and we don't want that. So how is this going to work? Well, first off, we need to scatter based off of scatter points and not density. So now we're switched over to that field. What I'd like to do is create a check to see if there are any positive voxel values. There's a few ways of doing this. I find that a very straightforward way of going about it is to actually use a volume slice right here. We can say that we're looking at scatter points, and I want to promote this attribute, which we'll also call scatter points, to the maximum value. So we'll do an attribute promote, say, all right, look for scatter points, bring it over to the detail, and find the maximum value. So now we go over to our geo spreadsheet, we should see, boom, there's the maximum value that it sampled from this field. Once we have that value, what we can do is check to see whether or not it's above 0. And if it is above 0, then go ahead and run with a certain number of scattered points. Let's create a point wrangle, but we're actually going to set this over to the detail because we don't need to go over every single point here. First thing I need to do is bring in that maximum value that was promoted right here. So let's say gather the scattered points right there. So gather scatter points, and that's going to be a float, is equal to the detail function. Look through input number 0 and look for scatter points. All right, now that we have that info, we'll say if our gather scatter points, so gather scatter points, is greater than 0. Open curly bracket, then go ahead and set a new attribute, and we'll call this a float that's scatter scale is equal to some sort of channel that we specify. So a float channel called scatter scale. And then lastly, we have a closed curly bracket. All right, so scatter scale, it's going to be 100. Again, if this maximum value is above 0, use this number. Now, to get this over to the scatter over here, right-click, and we'll say reference scene data, go over to the point wrangle, attributes, global, and we want the scatter scale. So now it's going to look at that. Okay, let's reset our sim. So we'll go out here, frame 31, give this a good test. All right, so we have frame 31. We go over here to the scatter. What's that? It's 100. Oh, that's great because I said 100 right here. Let's change this. Is it reading it properly? Sure is. Now, what about frame 29? Well, that's 0 now because it couldn't find any value under this if statement. So now it's working. Again, if we have this field showing any values of 0, the scatter stop is going to now behave itself, which is great. Okay, so that about does it for the scatter stop for right now. Let's go ahead and see what happens when we do a play blast just by gathering in these particles now. Okay, and now as we can see, we have this initial burst. They start dying out, and the only new points exist with density. So that's exactly what I wanted. Let's also keyframe down the scatter amount starting at around frame 49, and we'll have it last till maybe a little bit over 60. But this is exactly what I was hoping for. I was hoping for that initial burst that will boost those swirls, that will essentially add extra temperature. Like I said, you can use fuel if you want to have expansion right there. And from there, we can just manually animate this out. But that pretty much does it for the inside vorticles of the plume. For the next test, I'm going to try out the fuel method instead of temperature so that you can see what that looks like. And what we'll do in the next video is focus on sourcing vorticles outside the plume and using those vorticles to create cold air or velocity that pushes in towards the plumes. So that'll be really fun and exciting and life-changing in the next video.